Okay, how's everybody doing? How did it go with assignment 9? Okay-ish. It's a bit of an open-ended assignment, so there were some questions that just say, do this as fast as you can. It's hard to know sometimes when you've got the best possible solution. That's true in general. I mean, that's true in all that we do in computer science. We never really know when we're finished. So for the next little while, we're going to start wrapping up this course and getting you guys ready for what's coming. So that means for the next 2 weeks and the next 2 assignments anyway, I don't know about the next 2 weeks, we'll be looking at Java, the programming language. So switching gears, switching to a new language, mostly focusing on the differences between Java and Python, and so your next 2 assignments will be written in Java. And then we'll wrap things up in the final week by sort of going back and looking over what we've learned, or at least what we were supposed to learn in this course, and getting ourselves ready for the final exam. So that's what's coming. But for now, let's talk a little bit about Java. So how many of you, yes?
Does that mean with 11 assignments that one won't count?
With 11 assignments, only your best 10 assignments will count towards your final grade.
Okay, so this will make 11.
That's right. So we will have 11 assignments, and basically your grade will take the sum of the 11 assignments, or the weighted sum, and subtract off the minimum of those values. So if you missed an assignment, or if you did really poorly on an assignment, it actually doesn't count. So you get one freebie. So Java. How many of you programmed in Java? Okay, good. A good chunk of you. So what's your impression then on differences between Java and Python?
Python's way better.
Python is way better. Better in what way?
It's so much easier to write the code.
Okay. It's much easier to write Python code. Yeah.
I'm going to say it's more intuitive.
It's more intuitive. It looks a little bit more like English when you're actually reading it.
It's shorter.
Shorter, yeah.
Java has a really structural approach, like everything has to be in method.
Yeah. So Java is very highly structured. Yeah. It feels more detailed, like you're working at a lower level somehow. That's true, but it needn't be. Once you get familiar with the Java, the libraries that are available in Java, you should be able to do a lot of things at a similarly high level, but still somehow the syntax seems to get in the way and make it a little cruftier. Any other thoughts on the differences? Yeah?
It's made by a group of like so many people that like there's a lot of different ways to do this.
Yeah, so that's a good point. So Java and Python evolved in very different ways. So Java was created in the 90s, and it took some baggage along with it. They wanted to make a language that looked like C and C++, but they wanted to simplify it and clean it up a little bit. And they had this notion that people would want to run Java programs on the web. So there's some stuff around that. But it was done by a group at Sun Microsystems, and very quickly took off. And then there started to become standards around it, and committees and things, and it kind of grew in a committee way. There was no dictator, and it kind of grew out of control in that way. Python, on the other hand, was basically, for the longest time, was tightly controlled by one person. What's his name? What's the name of the Python guy? Guido, yeah, Guido. It was controlled by Guido with a Dutch last name. And he basically made all the decisions about the way this language worked. Even in the early versions, he broke backwards compatibility a few times because he decided that he made some wrong decisions early on and decided that he would just say, forget it, let's scrap those decisions. It doesn't matter if people's code stops working, they'll just have to rewrite it. Whereas in Java, that almost never happened. Basically, programs that were written in 1995 still compile under Java. I know that because I wrote such programs in 1995. So they evolve differently in that way, and it definitely shows. Any other differences? Yep. Python lists are way better than Java arrays. Agreed, but I would say that the two are not comparable. Python lists are closer to, in fact, they're almost exactly the same thing as Java's array list class. Yes, list comprehension is a very nice, piece of syntactic sugar that makes it easy to express a lot of things. And Java is starting to get there now. If you look at the features of Java 8, you will find things like lambdas and maps and stuff that start to get it closer, but still a bit more syntax heavy. Okay. So any last differences? Yeah.
The types of variables are not strict.
Okay. So Java, the types of variables are more strict. Java is what's called a statically typed language. That means that everything you define in Java, every variable and every function and every argument to every function, you have to say, when you declare a variable, you have to say what kind of variable it is. What does it store? Is it an integer? Is it a floating point? Is it Boolean? Is it a member of a certain kind of class? And that's true for functions. You have to say what kind of thing that they return. It's true for the arguments to functions. You have to say what kind of arguments are accepted. So it's very, very strict that way. And that means there's some kinds of flexibility that are just not available to you in Java that are in Python. So Python uses what's informally called duck typing, which means that if it looks like a duck and it acts like a duck, then you can just pretend that it's a duck. So, if you have Python functions that will do things like add their two arguments together, then you can pass them anything as long as the thing you pass is able to add. So as long as it implements the plus operator. And so that's a nice flexibility you have in Python. In Java, that's not the case. There is something called interfaces, which allow a very restricted version of that, but it has to be all very carefully planned and meticulously thought out in order to work. It's not just something you can do after the fact. Yeah.
Are we going to use NetBeans or Eclipse?
I am not going to use any IDE. I'm going to keep doing what we've been doing, editing with a text editor and compiling and running from the command line. Okay, so that's one big difference between Java and Python, is that Java is statically typed. And we'll see that means a lot of very careful thinking about things. Is there another big high-level difference? So how many of you have used Java from the command line? Yeah. How many of you have compiled and run programs from the command line? Okay, so then what's a big difference between a Python program and a Java program? Java is a lot faster. Yes, can be a lot faster for most things, but is there an extra step involved?
You have to create the class.
although in a second or shortly that it is also interpreted, but that's for another reason. So that means when you write a Java program, which is, a text file that we can sort of read and try and understand, although it's a little bit more effort than a Python program. When you write such a thing, it's actually a two-step process to get it to run. The first thing you have to do is compile it. So that takes it from this programming, this text file that we can read, and turns it into something called bytecode that a machine can read. So you do that once, and then anytime you want to run it, you're done with the Java file. At that point, you're running this bytecode file. And so that makes a big difference, and both in terms of performance and in terms of sometimes extra work. And that difference is often lost when people use integrated development environments, because all they do is write code and then press play and the thing runs. So they don't actually see that this is a two-step process, and it's an important distinction between the two. So Java is a compiled language. When you compile Java, it gets turned into bytecode, and then it's that bytecode that's executed on a machine. Now, I also said Java is an interpreted language. And that comes again from the history of Java. For some reason in the 90s, and still today, people were very concerned about letting their source code to their programs be distributed. So they didn't mind distributing the executable parts of their program, so the parts that people could run, but they didn't want to distribute the source code. On the other hand, for compiled languages, that's usually causes a lot of grief, because different computers require different kinds of code to run. And even more so back then, when Macs used different kinds of processors than PCs, and then Sun Microsystems, the developers of Java, they use yet another kind of processor in their machines. And different operating systems have different formats for executable files and what they should look like. So that meant if I was a software distributor, then I'd write a bunch of code, and if I wanted to sell it across a lot of platforms, like to Windows machines, to Unix machines, to Linux machines, to Macs, then basically I would have to compile my code 4 or 5 times and make those different executables all available, and then make sure that the person who needed a certain executable actually got the right one, and it was just a management disaster. And around the 90s was also the same time that the World Wide Web became popular. Basically, the first web servers went live in the 90s, and so they thought there was a need for software that could be distributed on the web, and not the kind of thing where you had to keep, you should go somewhere and get a piece of software and select your particular binary from a list of 20 possible binaries, hoping you got the right one for your computer. So they decided to make what's called a virtual machine for Java, which is not a real machine, just something that was a machine that's completely specified. Its instruction set is completely specified, and it's basically everything about it is completely specified. And when you compile Java code, what you get is an executable for the virtual machine. And now to run this thing on a real computer, you actually run something called a virtual machine emulator, which runs this thing on a real machine. So the idea was that, yes, every different system would have to have a different kind of virtual machine emulator. That's the real thing that runs on the computer hardware. But once you did that, they could all run Java programs. That was the hope that this would work. And it does work more or less. There's some, fair bit of software written in Java that ships this way and runs across a wide variety of machines, but it didn't really have the promise that, it didn't really live up to the promise. So as a result, though, it means that Java is both compiled, so you have to be, and static, and so you have to be really precise about things and careful about types and everything else. That's part of what happens when in compiled languages. But in addition to that, it's also interpreted because you're actually interpreting this bytecode, so it's actually not as fast as languages like C and C++, which are not interpreted, which actually run on the computer hardware. So it's sort of somewhere in between, and what you gain for that is a portability that you don't get from C and C++. Okay, so that's the sort of high-level view of things. But now let's jump in and actually start doing some, write our first Java program. So it was decided by the Java developers that this would be an object-oriented language, and there would not be a nice facility for just writing procedural programs. So the difference between the two is in object-oriented languages, you write classes and that define these, with those classes you can create instances of them, objects, and they all have methods and run, whereas procedural programming is what we did for the first part of this course, and actually throughout, where you just write functions that, return values and do what they're supposed to do. So as a result, everything you do in Java has to be part of some class. So we want to write a hello world program, which in Python is just a one-liner that says print hello world. But in Java, the first thing you come across is that everything you do has to be part of a class. So to write a hello world program, we have to create a class. We can call it what we want. I'm going to call this class hello world. And now a little detail of Java creeps in, which is that classes, at least public ones that you expect to be used externally, have to be put into a file whose name is the same as that of the class name. So I want to write a class called hello world. I have to save this in a file called helloworld.java. So okay, so far so good. I've created a class called hello world in a file called helloworld.java. And then there's this extra keyword here that we've never seen before in Python. It's called public. And that sort of means what it sounds like. It means that this class, so it's a modifier for this class, it says this thing is public. I would like anybody who wants to be able to access this class, create instances of it, or access its methods. So it's not hidden from anybody. Anybody can use hello world. Okay. Great. So now we've created a class called hello world. So that's fun, but we're not even close to printing anything yet. The next thing you learn about Java is, well, if you have to be object-oriented and you have to be, everything has to be an object, well, you still need a way to make programs that run. You can't just create a bunch of classes because by themselves, classes don't do anything. So if you remember our Python programs, even when we were doing object-oriented programming, we would usually write a bunch of classes, and then somewhere at the bottom of the file, we would create one of those instances of those classes and run it. So we might do something like call my game, and that would create an instance of this game, and then run that thing. So we need something similar in Java, a place where your program starts. So some Java classes are what's called runnable, and if you want your Java class to be called runnable, you have to define a method called main inside that class. Okay, we're almost there. So, now my Hello World class is runnable. It has a method called main. If I try and run this class, that's what will get executed. If we dig through the details of this declaration, we'll see that main is public, so anybody can call main. In particular, we can execute it from the command line. The void here means that main, remember in Java, every function has to have a return value. Void says there's no meaningful return value from this function. The return value is ignored. We're not going to actually return anything. So we've declared that this function doesn't return anything. So that's the name of the function, main. And it takes an argument called args. And that argument is an array, that's what these square braces mean, of strings. Okay? And then finally, the last word here is static. That says that this method is a class method. It's a method that I can run without having any instance of this class created. So these are the things that in Python are just the regular functions that you write, not inside a class. They're just the functions that you run. So, you know, in Python, the equivalent might be something like well, in Python, the equivalent would be this. In Python, the equivalent would be this empty file, actually, at this point. But let's say you insisted on creating a class. In Python, you would say something like class hello world, subclass of object, and nothing there so far. So you create this class, and then you have you know, somewhere some function that runs or does something. I mean, so far, this thing still doesn't do anything. All we've done is create a class. Now we want to print hello world. So, and now finally we have a complete Java program. What does this line do? Well, in Java, there is a class called system. System, that class, has a static variable called out. Out is a print stream, something called a print stream, so it's an object of the class print stream. And print streams have a function called print line, which prints some string on them. So we call that function, and we pass it the argument hello world, the string hello world. Okay, and then finally, everything in Java, every statement in Java has to finish with a semicolon. So it's not enough to just hit enter at the end of a line. You have to put a semicolon there and to tell it that this line is over. And a couple of other things you may have noticed. There's these curly braces here. In Python, blocks of code are denoted by indenting them correctly. In Java, they're denoted by these braces. So these two braces here and here tell us that this class starts up here and finishes down here. And these two braces, this one and this one, tell us where the function starts, the function body starts, and where the function body ends. Okay. All right. So this is our program. I believe that it works. I don't think I made any mistakes in it. But let's just think about this for a second. So So do you see why I don't like Java as an introductory programming language? So if we had started with Java, this is basically what we would have to do on day one before we could get through anything. And that's fine, but the problem that I have with this is the typical way that this is taught is you want to get to the good stuff, to start actually writing programs that do things. And so people generally say, well, I don't want to have to explain what a class is yet, because that's kind of a complicated concept. And I don't want to have to explain what public means, or static, or void, or this funny arrays, because at the beginning of this, you don't even know what arrays are. And so what typically happens is you get told, well, to write a Java program, the first thing you do is you write all this stuff, and then you put your code inside this block main here. And then you're told, oh, don't worry what this does, we'll tell you later. And the later comes much, much later throughout the course, and maybe you never learn. And I don't like that. I like to be able to explain everything that you see, to have it explained more or less completely at the time that it's seen. But Java just doesn't lend itself to that, unless you want to spend the first 2 weeks talking about classes and access modifiers like public and protected and so on, and the different types, including void and arrays, which, how do you talk about arrays when you don't even know how to write one line of code yet? So I'm not a fan of starting with Java. On the other hand, we've done so much already with Python that we've seen most of these concepts now. We know what classes are, so we know what's happening here. We know what arrays are, so we can, when I tell you that this is an array of strings, well, you know what that means. And static, it's not really a concept that we have necessarily in Python, but we know what these functions are that just execute, these functions that are at the top level in Python, and that's what these things are. And this access modifier public, I can tell you what it means. It means anybody can call this thing. All right. So let's, so I said that running a Java program requires 2 steps. The first step is compiling it. For that, you use the Java compiler. On the command line, that's Javac. And you give it the name of a Java file to compile, or a whole bunch of Java files if you want. Okay, so that compiles, and if I look in this directory now, I'll see that there's hello-world.java, and there's also hello-world.class. We want to run this thing. So hello-world.class is the bytecode file that we're going to run. And now here comes the first trip up. We want to run this program, and for that we call Java, not Javac. Java is this virtual machine that knows how to read bytecode files and run them. But the argument that we give Java is not the class that contains the bytecode file, but rather the name of the class, just hello world. Putting hello world.class here will not work. It will complain about a class not found error. It'll be very confusing because you'll be saying, look, the file's right there. Why can't you find it, you stupid thing? But that's because you're not supposed to give it the name of a file. You're supposed to give it the name of a class. And now, the moment of truth, we run it, and it prints hello world. Okay. So, any questions so far? Yeah.
When you compile the file, does it take the name of the Java file or the name of the class?
So the question is, when I compile the file, does it take the name of the Java file or the name of the class? It takes the name of the Java file, including the .java extension. Now, one thing that I mentioned, and I'll say it again, the name of the class has to match the name of the file. If it doesn't, so if I say, call this class Hello World, and I try and compile it, I get an error. It says that the class Hello World is public. It should be declared in a file called helloworld.java. So there's an error on basically on the first line of this code. The class name does not match the file name. So you can't get too far if you don't manage that. Yeah.
Would you be more specific error messages than error?
Well, I mean, this is fairly specific, no? Error, hello world is public, should be declared in a file called helloworld.java.
Oh, I didn't see that.
Yeah. And that, it even tells you how to fix it, more or less. No. Okay. Questions so far? Yeah.
If there was an error in your code, what would in the command line,
If there was an error in my code, well, we can put an error in my code. Here's a pretty common error. This code is now incorrect. Let's compile it. It tells me there's an error, semicolon is expected, and it's pointing, gives me a little arrow pointing to right in the place where it's expected. Yeah. Sorry, what?
Like if you have like a character class or something, and you have more than one type of that character that you utilize, and you have one static variable for like their health, then will that change all of their health? Or will that just change the health?
Well, no, a static variable is something that's part of a class. So every instance of that class shares that variable. Those we've seen in Python, they're the variables that are not attached to self, but they're actually declared in the class. We use them in our games at the top of the class. Often we'd have file names embedded in those, or images, or stuff that was shared by all instances of the class. So if you change one of those, it changes it for everybody. Okay. So there's a really common error. Get used to that one. If you learn programming in Python, you're going to get this one all the time, even if you've been programming in Java for 20 years and you've been doing just Python for a little while, you very quickly forget to start putting these semicolons here. At the end of every line, you need a semicolon. Okay, so we're back to our working program, and of course, compile it and run it. And don't forget this if you're working from the command line. Hey, why didn't it print this is really the end? Yeah? Yeah. So this will be something many of you will do. You go and you change the class file or change the Java file, and then run it to test it. And for some reason, your changes have not taken effect. That's because all you changed was the .java file. Now you have to remake the .class file, and to do that, you have to compile the .java file again. Okay. So if you find you're getting frustrated because something like that is happening, take a step back and think about the steps involved in running a Java program. Okay. So Java, for many people, is the kind of thing that wrecks laptops, especially for novices. Fists go through keyboards or through screens. Please don't do that. Have a little bit of patience with it, and please see a TA before it comes to destroying your laptop. Okay, good. All right. So in Java, every variable has a type. Java has different kinds of comments as well. So if you have a one-line comment, you can, where in Python we use the hash character, you use 2 slashes. And if you have a multi-line comment, you can pinch that between a slash star and a star slash. Okay. So those are the 2 kinds of comments. They're useful. So I'm using them here because I want to keep track of some stuff that I'm telling you. So Java, everything you declare has to have a specific type. And there are a bunch of types. There is the byte type. So what's a byte? It's an integer that can take on 256 different values. And that means it is actually represented using 8 bits. Does anyone know what those values are? Yeah. I believe it is. Let's try. So I want to declare a variable x, which is a byte, and I want to know, can I set it to, let's say, -27? If that's even allowed. Yeah. So it's negative and positive numbers in the range -128 to 127, positive 127, I believe. Now the nice thing about Java is if you try and do something that's not allowed, like if you set a byte to -129, it'll complain that there's an error here. You tried to set this byte to a value that it doesn't take on. So you might lose precision, whatever that means. We'll see what that means in shortly. Okay. So there's byte, which can go -128 up to 127. There is short. That's just longer than a byte, 16 bits. How many different values can you represent with 16 bits? Everybody should know this.
536.
Yeah, 2 to the power 16. And again, those are minus 32 something up to plus 32 something. So half of 65536. Okay, there's also int, which is 32 bits. How many different values can you represent there? Roughly?
4 million.
Yeah, so about 4 billion different values. And that's about minus 2 billion up to 2 billion. And then there's long 64 bits, and that's lots of different values. 2 to the 64 of them, and it's pretty big and small integers. You've also got floats. Floats we have seen. We have these in Python or something similar anyway. They're 32 bits, but that's not important. These things represent, like real numbers. They're the floating point numbers that we've seen. And remember to be careful with them, just like in Python. The arithmetic that you do with these is not exact. So if you add two floats together, you may not get exactly their sum. In Python, we saw the glaring example of that, where we did something like took 0.3 and subtracted 0.1, and we didn't get 0.2. We got 0.199999999. The same thing will happen in Java. And there's also double, which is 64 bits. And this is just a more precise version of floats. But again, arithmetic with this is still not exact. So there'll still be errors. They'll just be, they'll be at the 10th decimal place or the 12th decimal place instead of the first one. We have Boolean, which is a bit, you can think of it as 1 bit, true or false. But unfortunately, you can't just store 1 bit in a computer. You have to store at least a byte. But it only can have 2 different values. And you have characters, which are 16-bit Unicode characters. So the ASCII, the 8 bits is not enough to represent all the characters we like to use nowadays. We like 16 bits. So about 64,000 different possible characters. Remember in Python we could do something like, we could do lots of nice things, like for example, a million times a million, and we get a nice answer. We get the correct answer. In Java, you have to be a little bit more careful. So this is, similar to this Python code where, you say x is a million, y is a million, and z equals x times y. We look at the value of z, it's indeed a million times a million. Now if we do this in Java, so what gets printed? So we're computing a million times a million. Should be a 1 followed by 12 zeros, right? Yeah, but if we look at ints, we said they can only go up to about 2 billion, so something's going to go wrong here. And indeed, what comes out is a negative number. So a million times a million ends up being a negative number. And that's because a million times a million is bigger than 2 billion. It's more like a 1,000 billion. And so it's too big to fit in an int, and it kind of just wraps around a bunch of times. So once it gets past the 2 billion or so mark, it becomes negative, and then it wraps around again. So it wraps around actually, a whole bunch of times, and eventually it finishes off there at a negative number. So integer arithmetic, you have to be careful with it. If you multiply things that are too big, you'll run into problems. Even if you add things that are too big, you'll run into problems. If you wanted this to work, you could use long integers instead. And then you get the right answer. But that only works up to a point, right? That's just because 1,000 billion is within the range of a long integer. But if we added a few more zeros, we'd run into the same problem again, even with these long 64-bit integers. Something else you should look out for is so we take 3 and divide it by 2 here, and we print the result. So what's the answer? 1. So because p is an integer, it does integer division, and so we get the answer should be 1.5, but we just get only the whole part of that, the integer division part. And that's true even if we try and do this just by something like this. We still get the same result if we take 3 divided by 2. Do you know how we would get the result we want? Yep. Yep. If we do what? There's a few ways to do it, but we needed to tell it to use floating point arithmetic, and it's not doing that because both of these arguments are integers. So we need to indicate that there's some floats in here. We want the floating point arithmetic. So it's enough to just put a dot after this number, at which point it'll do floating point arithmetic. So if you give it even 2 integers and you ask it to do some math on those, it'll do integer math. But if one of the numbers you give it is a floating point number, it'll do floating point arithmetic on that. Okay, and then you run into errors if you do things like something like this, or even if I do 4 divided by 2, which is an integer. Oops, there's the famous semicolon error. So even 4 divided by 2, I know that the answer is an integer, but Java's unhappy because I said 4 is a floating point number. So it's going to use floating point arithmetic. It's going to give me the floating point number 2, but then I'm trying to assign that to an integer variable p, and it doesn't like that. It's going to warn me that, it tells me there's a possible loss of precision. You may lose some digits. Yeah. Oh yes, you have to import lots of things in Java. We'll see some of those things. There's a huge class library in Java, some of which is always available, and some of which you have to import every time you want to use it. Yeah. Is the spacing in Java important? No. Spacing in Java is completely irrelevant and Java doesn't care. What it cares about is the blocks and the semicolons. Semicolons are used to say that a statement is over. In Python, that's just a carriage return that would do that. And the blocks are used to denote blocks of code. In Python, to do that, you just make sure all the code is indented to the same level. Java does not care at all. The only reason you do spacing this way is so that a human who's reading it can easily recognize where blocks start and end. Yeah.
Before we ran an issue with the end topic going on to do another.
Okay, so can you guys stop talking, whoever's talking over here? Yeah.
Yeah, before we had the issue with billions and billions of bins. So, is there any time where you wouldn't want to use longs to store numbers?
Is there any time when you wouldn't want to use longs?
Yeah, because they have the biggest data amount, so why not use them every time?
If you're worried about memory, then they also use twice as much memory, so that's an issue. There's also a problem that we'll see. There's this big class library, and this class library includes a lot of functions that take, those functions take arguments, and including, sometimes those arguments are ints. Now, if you're using longs everywhere, that means every time you call one of those functions and you try and use one of those longs as an argument, Java is going to get mad at you and say, you're converting from a long to an int. There's a possible loss of precision. I don't want to do that unless you explicitly tell me to do it. And then for that, you have to wrap some, you have to explicitly tell it. And that means everywhere in your code, it's full of these things where you're saying, oh, take this long and turn it into an int. And for many things, 4 billion is enough. Like, Java just does not even support, there's no way in Java to have an array whose length is bigger than this 2.5 billion. So if your thing that you have is just an index into an array, there's no need for it to be long because it can't actually, you can't have arrays that are longer than 2.5 billion. So that's the reason that you still use ints. Not just about saving memory, but you just run into, you run up against a lot of limitations that are present in the library. So there was a question here, yeah?
This Java, when has like decimal, do they use floating points or double floating?
It's using, I think it just does float. You mean if you do something like these literals here? Yeah, I think then it's just using float. So we can test that by trying to compile something like this.
It says it probably double.
Oh, no, it actually uses double. So it'll use, by default, double precision. And so if you have an expression like this and you try and assign it to a float, again, it's going to complain. It computed this really nice, precise answer, and you're throwing away all its hard work. It doesn't want you to do that. It wants you to be specific about that. And to do that kind of thing, it is allowed, it's possible, but you have to be explicit. So you do what's called casting. So you write the name of the type that you are trying to turn this result into. So in this case, I would like it to become a float, and you just put it in brackets before the expression. So now it's doing exactly the same thing that it was asked to do before, but you've explicitly told it, I want this turned into a float. I know that this may mean that I lose some precision, but I told you explicitly to do this, so leave me alone. Stop complaining. And similarly, you can even go to an integer that way. So it'll just truncate that float and turn it into an integer. Okay. Questions so far? Good. All right. Arithmetic expressions. These are just like in Python, except that there's no exponentiation. So there's no exponentiation operator. It's just not part of the Java language. And that means it follows the normal BEDMAS rules of precedence, except without the E because there's no exponentiation. There's not too much there except to, be careful if you're mixing integers and floats or integers and doubles or longs and ints. Anytime you do that, Java will upgrade to what it thinks is the most precise type. So if you take an int and a float and you do something with them, add them together, what you get back is a float. If you take a long and an int and add them together, what you get back is a long. So it'll upgrade to the more precise arithmetic. And it also has this last thing, including comparison operators. So less than, greater than, less than or equal to, and not equal to. And their level of precedence is right at the end here. All the arithmetic gets done before you compare things. Okay, so there's a huge class library in Java. So I said Java does not have exponentiation operator, the 2-star operator. But it does have a class called math. And math is full of static methods. So you'll see many, many static methods here for taking absolute values, cosines, sines, tangents, and including a POW, which takes two arguments, A and B, and computes A to the power B. So that's the replacement for exponentiation, is you use the math POW operator. And one thing you may notice here is the absolute value function appears 4 different times. And that's because there's different functions, one for if the argument is a double, one if the argument is a float, one if the argument is an int, and one if the argument is a long. So you'll find many things repeated there for that reason. Okay. So if I want to compute 2 to the power 10, I need to call math.pow. Okay, so 2 to the power 10 is, according to this, is 1024.0. So it calls it, but it turns it into a double at the same time. So you put in 2 integers and you get a double out of this. Okay. All right, what else does Python have that Java has? Arrays. We've seen an example of an array, args up here, but there's other ways to make arrays. So let's say we want to make an array of integers. We can do something like this. So here we are saying I have a variable called MA, my array. What kind of variable is that? Well, it's an integer array. So it's an int array, that's what these brackets mean. And what's the value of that thing? Well, I will create a new integer array of size 10. So that's what's going to be there. Okay. So you have these things. And Java, like Python, has more than one way to create an array. So you can do something like you can also create an array just like that. You use curly braces instead of the square braces, and you just list out the elements in the array. And again, this is an int array, so I'd better only list out ints inside that list. If I try and put something else, I'll run into trouble. You can iterate over arrays, just like you do in Python, using a for loop that looks similar. So for loop that iterates over an array, you specify the variable that you want to use for the iteration. In this case, I want x to take on every value in the array NA. And of course, remember every variable, you have to say what its type is. So I have to tell you that x is going to be an int. It doesn't just infer that from the fact that NA is an array of ints. And it's unhappy that I've already used the variable name x up here, so I better pick another one, xx. And so that iterates over those values in that array. That's good, fine, but we need something a bit more than that. Sometimes we don't want to iterate over the values in an array, we want to iterate over the indices. Yeah.
So if I want to give x a new value, I can't just replace it with a new x?
You can replace it with a new x, but that'll be a problem here because, I mean, I could try and say something like, x equals 56 or something like that. That would work. Or I could have even said, here, don't declare a new variable named x. Use the variable x that we already have. But that's a long, and these are ints. Let me just verify that that really does work. Nope, didn't like that. No, can't do that. Scratch that. So you can change the value of a variable, but you can only change it to something of the same type, and it seems you can't use a variable just inside a, you need a new variable for a for loop. Okay. Now sometimes we want to iterate over not the array, the elements in the array, but the indices in the array. So how do we do that in Python? Like for instance, one of the first things we did was learn how to set an array to all zeros in Python. So what do you do? Yeah?
Did you just set xx equals 0?
Well, let's see. So if I go through this thing and set xx equal to 0, and then we'll go through it again and print out xx. So did that set the array to 0? No, didn't change it. And that same thing would happen in Python. We have a variable that takes on the values in the array. If we change the value of the variable, that doesn't change what's in the array. So what did we do in that case? Yep.
Did we address the current cell in the array MA?
Yep. So how did we do that in Python?
Was it MA and then square bracket and then the index of the cell and then equals the number we wanted?
Yes, but how did we get those, how do we iterate, how do we get those indices, 0, 1, 2, 3, and so on? Yep.
We iterate to the range of the length of the array.
Yeah, so in Python, a real common pattern is you say something like, for I in the range len of A, and then I will take on all the values 0, 1, 2, 3, 4, 5, all the way up to len of A, and then you're good, because you set, you know, A at I equal to 0, or A at I equal to whatever you want it to be. Now, Java does this a very different way, and this comes from the C tradition. In Java, you have a really wonderful thing called a three-part for loop. Looks like this. So the way we would set this thing to 0 is we would say for I equals 0, okay. So there's this thing called a three-part for loop. You write 4 parentheses and you put 3 statements in there. This first statement, I equals 0, says the way you start this loop is you set I equal to 0. The second statement says the loop is done, or the loop should keep going rather, as long as I is less than the length of the array. And each time the loop executes, you set I equal to I plus 1. Now, Java has these very handy increment and decrement operators, so you'll never see a Java programmer write I equals I plus 1. You will see them write I plus plus. It means the same thing. Except it even has a value, but that's not something to worry about right now. So that just means add 1 to I. And this is exactly the same thing as a while loop that looks like this. Well, we should finish this for loop maybe. Okay, so this for loop here translates into exactly the same code you would get if you have this while loop. So before you start, set I equal to 0. As long as I is less than a dot length, do whatever that block of code tells you to do. In this case, we set NA at I equal to 0. And then once you've done what the block of code tells you to do, increase the value of I by 1. And these three-part for loops, each of these 3 parts can be any statement that you want. But this is the most common pattern is counting with an integer this way. So let's see if that does what we expect it to. So now that set everything in there to 0. Okay. Good. These 3-part for loops are important. You'll see them in C, C++, Java for the rest of your life. The pattern is always like this. If you're iterating it over an array, don't lose it. I equals 0. I is strictly less than the length of the array, I plus plus. Not less than or equal to the length of the array, but strictly less than. Get that wrong and you'll make an off by 1 error. In some languages that can be really hard to find. And then of course, embedded in all that is to get the length of an array, you say dot length. Okay. Now, these are all the basic types. These are so-called the primitive types that are in Java. And there's one more primitive type, reference. So a reference is a reference to an object. And in Python, actually, we only had one type. Everything was a reference to an object. In Java, this is different from the rest. It's this, reference to an object, and you'll see these things. The first place you'll come across them is with strings. So now S at this point is a reference to a string object. And if I look at the string class, I see that it has a whole bunch of methods in it. In fact, there's about, looks like 10 or 12 methods for actually creating a new string, and an additional method which is just to write the string between double quotes. And then a pile of other things, like there's a character at method, code point at method, an ends with method, an equals method, a whole bunch of these things, equals, ignoring case. There's a pile of these string methods. And these are things that we can apply to particular strings. So I want you to note the difference here. So character at, that returns a character, so it'll tell you the character in the string at some position, and you give it an index. And now compare this to the math library, which is the absolute value function, math.abs. So the way you use that, so notice there's this static modifier here that's not present when we look at character at. There's no static thing. So this says it's a property of the math library. If we want to use it, we say math.abs, and we give it a number argument. This says, because it's not static, it's actually a method that you apply to a string. So in particular, we can do something like character at, I don't know, let's say 6. So notice the difference here. This is calling the character at method of the string S. It's not a static method, versus something like that. Okay, so the 6th character of the string, the character at position S of this, or 6 of this string, is an S. It's the S in is, and the absolute value of minus 22 is 22. So that's the difference between a static method and a non-static method. Static method is just something that's in the class. You call it with some arguments. You specify it by putting the name of the class before it. Whereas a non-static method takes a member of that class, in this case S is a string, and calls the method on that. We've seen this in Python, but it works in a slightly different way in Java, and that's just because everything in Java has to be inside a class, even methods that it doesn't really make sense for them to be inside a class. But when you have such methods, you just call them static, and then you use them as if they're available to anyone. Okay. A couple of other things to look out for. No single quote strings. So in Python, we could use single quotes or double quotes, whatever was convenient for us. Java single quote strings don't work. They're used to define characters. And there's no multi-line strings. So in Python, we could use triple quotes and get a string that goes across many lines. Java, you just don't do that. The escape characters in strings are roughly the same as in Python, though. So you can have new lines inside a string by putting a \n. Okay. I've seen that. Aha. And something else you may need for your assignment is, so we know how to print things now. You can call system.out.println or system.out.print. How do you read things? Well, turns out that that's a little bit trickier. You read from system.in, but not directly. You create something called a scanner on top of system.in, and oops. See if all that works. Scanner is maybe it's in util. Okay, so so you create this thing called a scanner. On the system input, you can create scanners for other things like files and so on. It's just an interface wrapped around something that lets you do a bunch of stuff. And in this case, I'm asking the scanner for the next line, and this is roughly the equivalent of Python's raw input. So now I type something here. And this, prints you input, this is it. Just as you expected to. And one thing that happened when I first tried to compile this is it told me that scanner is not found. And that's because scanner is part of the Java class libraries, but by default, not everything in those libraries is available. Just like in Python, sometimes you have to import things. And in this case, I had to import there's a Java package called java.util, and in that package is a class called scanner, so I imported that so that I could use it. And that's pretty much where we should stop for today.